Welcome back, binary counter. What is this? How do they keep coming up with this stuff? Okay, well, welcome to the counting machine. Let's see. Okay, the goal here is to make that big green screen go from 0 to 15. 1, 2, 3, blah, blah, 15. Sounds easy enough, but you need to represent those numbers in binary using those 4 green sensors on the left. How do you use those sensors? Just put a cube on them to turn them on. When you have the sensor inputs set up how you like them, someone needs to press that big red button, and this will scrape the sensor inputs and convert them into a number on that big screen. The first sensor all the way on the right represents 1, the next sensor represents 2, then 4, and then 8. The red button adds them all up, and blam, displays it on that green screen. It's also simple. Okay, cool. So, what we'll do is this person will step down. We're gonna probably need to use our signals, but basically, this person will step down. Everyone needs to pick up their cubes. Might as well get that taken care of right now. So, we're gonna have everyone step down, and we're gonna have them pick up the cube that they're standing on. Once they've done that, we need to have this logic where... Okay, person puts it down, then they alternate, then they put it down, they alternate. Alright. So, there's a fairly easy way I can think of to do this, which is, everyone's gonna keep track of what counter they are. So, if there is no worker, if to my right there is no worker, then I need to, what should I do? Basically, okay, so if I need to basically assign everyone their role, and that determines how long they're gonna wait as they do their counting. So if to my right is not equal to a worker, what I will do is I will tell everyone hi. No. Okay, so how do I do this? It's sort of like I need to tell this person like 1, then this person 2, then this person 3. But I'm kind of lazy. There might be an easier system than that. So what I could do, because I can just basically pass these messages down here. So I could have this person basically just count out some sort of blocking thing. Anyway, what I'm thinking is that, based off of what their number is, this person is going to just pick up their... this person's going to just constantly be walking back and forth. This person's going to walk back and forth for every 2 times this person walks back and forth. This person is going to walk back and forth while holding their cubes every, like, 3 times that this person does, and this person... Or rather, it's going to be 4 times for them. And then this person's gonna do it, they're gonna wait for 8. So, oh, got it. Okay. We do this via powers of 2. So, basically the way it will work is, I will set my base to 1. Everyone sets their base to 1. Otherwise, what I will do is I will, if to my right is not equal to a coworker, I tell everyone to my left, hi. Otherwise, I listen for a hi, and then I tell everyone, or I tell the person to my left a hi. So what this will, I need to eat one hi for everyone that I receive. So I will listen for 2 highs, and then I'll tell one. So, what this will do is I will then, I need to calculate this in a very interesting way. So for every hi I receive, it's so like for every hi I receive, I need to, add up a number. I need to, like, count the number of highs that I get. There is a significantly easier way than this, which is if to my right is equal to a nothing, then I am base 1. Else, I will, okay, here's what we're gonna do. This is gonna be nuts. I need to do my stagger thing again, I think. So, if to my right is equal to nothing, then I set mem1 to be, 1. If to my left is a nothing, then I will set mem1 to be 8, as I am this person. Else, I will, how do I determine if, I see. If to my right is equal to a nothing, I will set mem1 to be nothing. Then I'm gonna pick up the cube beneath me. If to my left is a nothing, then I will check if to my right is the data cube that this person just picked up. Then I know that I am 2. Else, I am 4. Alright. That's hilarious, and that will work pretty well. So this person thinks they're 1, this person thinks they're 8. Jack thinks they're 4, which is wrong, because they should think that they're 2. I'm not too sure why they thought that they were 4. If to my right is equal to a data cube? They have a data cube, so okay. Well, here's the other thing. Instead of stepping up, instead of picking up, I can just step down. So if to my right is equal to nothing, there's no coworker there, then I'm 2. Alright, that happened a little too quickly. Jack thinks he is 2, and damn you game, stop doing that. Okay, let's check on Eve. Eve has gotten to the end. She thinks she's 4. So we have 1, 2, 4, and 8. Awesome. So, once we've done that, we're going to pick up our cube. Okay, another thing I'm going to do is, if to my left is a nothing, or if to my right is nothing, and to my left is not equal to a data cube, then I need to, not do any of this stuff. So this guy shouldn't do anything. So he won't move out of the way. Jack. Here's what we're going to do. we're going to step down and pick up our data cube. So that should get everyone holding their data cubes once they're assigned. Which is great. So everyone picks up their data cubes, and we will basically everyone's picked up their cubes, and then we're going to check if I have a worker to the left of me and I have a worker to the right of me, then I will tell everyone hi, else I will listen for a hi. So nobody will do any work until they, so that gets everyone here. Everyone is now at this instruction, which is cool. So, we're basically synchronized. Everyone's picked up their cubes in this line, and we can start our count. So, what we will do is, so we're gonna calculate something. So we're gonna do mem2 is equal to mem1. So basically, what we do is we have a counter. So this person basically toggles. So they will set. Everyone sets their mem2 to be their base. And then what they do is if their mem2 is equal to 0, then they will step down and drop their cube. And then they will... What we will do is... We should probably do a tell there, if everyone's perfectly synchronized. But we'll figure that out in the future. I'll do the counter, then I'll work on synchronizing with this guy. So if mem2 is equal to 0, then I step down and drop. Else, I'm going to calculate mem2 to be mem2 minus 1. And we have dropped it. We are then going to set mem2 to be mem1. And, okay, so we're going to do count. And then we need to do another thing where we pick it up and then step back up, basically. Or rather, everyone's got their cubes. So what we should do is do 2 steps down. And, okay, here's what we're going to do. We're gonna... Instead of stepping, we're just going to do pick up and drop. That'll be way easier to synchronize everything. So, we're going to step down, pick up the cube that we're standing on, and then step down again. So everyone should be standing on this thing. And I want to then know... basically, if... I reached here. If my, I want to find out what happens if I press on this red button. If I press on this red button and everyone is here and they're holding the cubes above their head, what I want to know is, does the game count that as 0 or does the game count that as 15? So if my mem1 is equal to 0, so I am this guy, he is 0, then what I will do is I will step down. So he will step on that button. It is 0. Good. That will be really nice. Alright. So, let's see what happens. They're there. They're doing mem2 minus mem1. Okay, cool. So we should see something very, very cool happen. That person standing on the button. They should drop one on the ground. They should drop that. So this button thing isn't exactly working the way I expected it to. Place cubes on any... Oh, okay. Okay, we'll work on this in a second. Alright, yeah, so nobody put the cubes down. So the big red button. So I will have to synchronize this a little bit. For now, I'm just going to take that out. Again, like I said, we're not going to bother synchronizing against this guy for now. My voice is very scratchy. Pardon me. So, I will calculate mem2 is equal to, or mem2 minus 1. Now, if I do a drop, then I need to set mem... We need to do a different loop. Where we set mem2 is equal to mem1. So I set it back to my base. And I will then do a countdown again where I pick up the cube at the end of it. So if mem2 is equal to 0, I will pick up my cube. And then we jump back to the counting. Else, I will calculate mem2 to be mem2 minus 1. Okay, so what we should see is she puts it down. Okay, we're at 2. Alright, this didn't quite work. Let's figure this out. Let's slow it down. So this is the person that's to watch. They calculate mem2 minus 1 to get 0. And that I wasn't paying attention, so I missed what they were doing. Okay, we're looking at Penny. They are going to listen for high. Okay, so she calculates mem2 to be minus 1. Alright, she should now drop it. And then, since mem2 is equal to mem1. Ah, of course. The issue is I don't have this looping. I have forgotten to set up loops many, many times in this game. Many of my puzzles have been thrown off by my forgetting to actually set a loop. So she's put down 1. We now have 2. That person picked up their number. Alright. So everyone, this is working kind of well enough. However, basically, what we need to do is, we need to synchronize this a little bit differently. So, how do I do this? I need to have everyone kind of on the same, like, cycle. But the problem is that calculating takes longer than dropping. So if I tell everyone high as just a random thing, then that will eat up a cycle, and that will keep everyone kind of in sync with each other in terms of how much computation they're doing. Nope, okay, those people are now desynchronized. I mean, in theory I'm sort of counting this, right? Let's see what happens again. So, it looks like calculation is actually 2 cycles. So they tell everyone hi, and then they drop it. Yep, so telling everyone hi is not slow enough. Let's tell everyone hi twice, and then do our drops and our pickups. Okay. They have said hi, they've said hi again, and then they dropped it. Which is wrong, because now these people are slightly desynchronized. So telling everyone hi may actually, I may need to do it 3 times. This is a very interesting approach to synchronization that I've developed here. It is not very professional. Okay, let me just start counting this in binary and see if I've kind of brute forced my way into having this work. I may not have synchronized it exactly, but I may have synchronized it well enough. So let's just start counting. So we're at 0. We're at 1. 2. 5. So that's wrong. Okay. Okay. There is a different way that I can synchronize this, which is, I can actually use signals. So, once I've dropped... I kind of know what I can do. So, this guy can listen to 4 signals in a row. And then, everybody, once they have done their... Once they've done a calculation, they need to, like, wait, basically. So, once you've done a drop... You then tell everyone hi. Okay. Okay. What's an atomic operation? An atomic operation is basically... As soon as one person has changed the state of all 4 of them, they need to, like, stop and wait for a signal. So, how to do this? Okay, let's actually see what happens if I just don't synchronize it at all. Because I need to get a sense of, like, what's actually happening. So they put down 1. So we're at 1. We're at 2. We're at... Okay, briefly we had 5, so something's not quite right there. Maybe... I need to set this to be 1 off of a power of 2. Like, what if I do this? Maybe this will synchronize things a little bit better. So everyone's in place. Okay, so we have 1. Okay, this person is just alternating like crazy. Almost. Okay. So you get what I'm trying to do here. I'm basically saying we need to do one cycle and then we pick up the number. This person needs to do 2 cycles, then they pick up their number. This person needs to do 4 cycles and then they change their number, and this person needs to do 8 cycles. So, but it's not cycles, it's like units of work. So I just need to figure out a way to make the unit take a consistent amount of time for every single person, and the difficulty is this calculate step. So what I can do is, once I do a drop, I need to pause. I need to listen for a signal. Ideally what I would do is I would have everyone stop when they hear this signal, but it's not quite correct. So they need to listen, they need to tell, okay, so they have picked up their cube, which means they need to listen, they need to tell this guy something, and they need to listen for a high, but that's too, it doesn't quite do what I need it to do. It's more that, like, what I need to do is I need to have everyone do their subtraction together. And if okay, I know what to do. We need that was close. That was actually really close. So, we will then calculate mem2 to be mem2 minus 1. And if my mem2 is equal to 0, then I know that I need to drop my item. So far, so good. Otherwise, I need to, once I've done a drop, otherwise I need to do a listen. So we can synchronize each cycle using this person. Got it. Got it. Got it. Perfect. Okay. Otherwise, I need to listen for a certain signal. We'll just use high for right now. And then this guy's going to be a little bit different. But basically, if my mem2 is equal to 0, then I do a drop. I will then tell everyone morning. So, like, this person has a very special role. Let's think about this. So, and they're 1, so they're always going to alternate. They've walked forward, they pick up that. Everyone's synchronized. They drop their cube, and they tell everyone morning, which means that it is time for this guy to basically walk forward and press the button. But what we'll do instead is we're going to enter a loop where if my mem1 is equal to 0, which means I am this guy, I will listen for morning. I will, in theory, I should step on the button, but I'm not going to do that right now. I'm going to tell everyone hi, and I'm going to just go in a loop here. Okay. They put down the 1, they tell morning. This guy then, he is listening for a high, which makes sense. Because we need to do this logic up here. So that this guy never enters the same sort of behavior that these people do. Except for the fact that he didn't seem to actually behave right. Okay. Oh, I see. I see. So instead, basically, if to my left is a data cube, then I know I'm this gentleman. So that's what we'll do. If to my left is a data cube, then I enter this loop at the very beginning of the program. So they all pick everything up. Okay, their computation cycles are now synchronized. She has said zero. She says morning. That person says hi. Everyone did not they didn't do their listen for whatever reason. That was really strange. Hold on. Okay, so this is going to... Their mem2 is not equal to 0, so they should be listening for hi. Okay, they say morning. They say hi. Everyone else has fallen off the, Okay, so then they listen for hi. Got it. Got it. Alright, once we've done this guy, when he hears morning, he needs to... So the first thing he's going to do is step down 1, so he's above the button. He listens for morning. He's going to step on the button to update the display. Then he's going to step off of it, and he's going to tell everyone to do another cycle. So I'm basically using this person to control the overall clock at which we do this counting. He steps forward, it's 1, he tells everyone hi. Nobody has any more loops, so obviously nothing happens now. They're gonna listen for hi, and they're gonna jump back to this thing. And what they're gonna do is, if I am standing on a data cube, then I will pick it up, else I will drop it. Let's see what happens here. Okay, that person has 0. They drop it. They say morning. This guy updates the display. He says hi. That person did not. Looks like nobody else updated because we didn't have the jumping statement where it needed to be, so that everyone was listening for it. So this should go back to here, and then this should go back to here. So we reset our counter once we perform either a pickup or a drop. Otherwise, we stay in this loop where we're just doing the subtraction. Everything should be totally synchronized. This is a very, very complicated puzzle, and I think I got it. So they put down 1. This person steps forward. They say hi. Everyone does... Yes, that looks great. They've done their calculation. They pick up that. 2. Oh, this is exciting. Everyone does the calculation. This person should drop theirs. 3. Yeah. Okay, everyone should toggle their state. 4. All right, if we've made it this far, then there's no way this program doesn't work. Okay, this person should drop theirs. 5, that's 5. Then this person should drop theirs on the next cycle, and they should pick theirs up. They do. 6, there it is. Learning how to count in binary is actually a really useful skill, and it doesn't take any time. Honestly, you just learn to like kind of alternate your fingers. And the cool thing about learning how to count binary in your hand, or using your hand, is that the binary number for 4, if you start by counting with your thumb, is the middle finger. So you can flip everyone off and then just be like, nah, dude, it's just 4 in binary. Alright, so everyone toggled. What? You did it? I got lost when I ran out of fingers to count on. I think I did alright. I didn't do great on size, but I think I did good on speed. I did not do good on speed. But I won. And that's all I care about. Cool. Yeah. I think I have time to take on a couple more tonight. Maybe not, we'll see. But, yeah, I guess not. But we will pick this up tomorrow, so thanks for watching.